All right, so this video is to give us an introduction to chapter 1, which is all about exploring data, and also give us kind of an introduction into what we're doing in statistics. So first things first, we need to figure out exactly what is statistics. And so when we're studying statistics, we are actually studying the science of data. And so data is any information that can be collected. It can be numbers, it can be values, it can be categories. So the statistics that we're doing involves collecting the data, analyzing the data, and then making predictions based off of that data. For our course, we'll also take some time to study probability as well, as that is essential to helping us with our predictions. So when we talk about data, when we talk about this information that we're collecting, the term individual refers to the objects that are described by the data. So these individuals can be people, they can be animals, they can be things, anything that we are going to be describing by our data. When we talk about our data, our variable is any characteristic of this individual that we will be studying. So a variable can take different values for different individuals. And we're going to look at some examples at the end of these notes. So first let's go through our definitions, and then we'll look at our examples. So for all of our variables, there are two types of these variables. The first being a categorical variable. So a categorical variable places our individuals into several groups or categories. Some examples of categorical variables would be things like hair color, gender, eye color, even something like an area code, okay? The other type of variable that we study is a quantitative variable, and we'll spend a lot of our time looking at quantitative variables. So important for us to note that quantitative variables take on numerical values where it makes sense for us to take an average. So some examples are things like age, GPA, height, weight, salary. Notice that all of these are numbers, they're numerical values. Area code is also a numerical value, but I told you that it was a categorical variable. The reason that area code is a categorical variable is because it is describing a location. It's grouping people together based on something that they have in common, their location. If we were to average out the area codes of every student in our class, it really wouldn't tell us anything. It wouldn't mean anything. However, if I were to average out the heights of every student in our class, now that numerical value, the average height, is actually going to tell me something about students in this class. So when we talk about our quantitative variables, there's also a distinction that can be made between two types of quantitative variables. So one of these would be what we call a discrete variable. And so a discrete variable takes on a fixed set of possible values with gaps in between. So examples of discrete variables include a lot of times counting. So the number of an object that we have. For example, the number of siblings that every student in this class has. That would be an example of a discrete variable because it's going to take on a fixed value, a number from 1 to infinity, but they have to be whole numbers without the possibility of anything in between. So there are going to be gaps between these numbers. On the other hand, a variable that is continuous is going to take on any value in a given interval. So things like weight, height, GPA, even maybe salary could be considered a continuous variable because they can take on any value in an interval. For example, if we're talking about the height of students in this class, people don't measure just 5 feet or 6 feet or 4 feet. They measure 4 feet and a certain number of inches. So they can be any value in a given interval. If we talked about weight, let's say someone weighs 150, it could be any value 150, 151, or 150.1, 150.2, 150.3. And we could continue adding those decimals. And so that's what creates that continuous variable, any number on a specific interval. Another thing we talk about when discussing data is distributions. So the term distribution refers to the values a variable takes. So what are the different options for this variable, and how often do these options or values occur? So as we move forward exploring our data, we want to make sure that we start by looking at each variable independently by itself without worrying about any other variable. Then we can start looking at relationships or looking for relationships between two variables. One of the ways we can start doing that is by looking at a graph or graphs and then move on to numerical summaries of that data. Now, the end goal in statistics for the most part is to use inference. So inference is the idea of using the data that we've gathered to draw conclusions that go beyond or expand on what we have in front of us, the specific data that we observed. So looking at the data for students in this class, can I take that information and make an inference? Can I expand on that data to talk about students at Columbus as a whole? Okay, so these are basically our definitions. We're going to look at some examples now. And should you guys have questions, we can obviously go over this in class tomorrow. So I have here two examples for us. So the first says, Jake is a car enthusiast who wants to find out more about the cars that students at his school drive. He gets permission to go to the school parking lot and record some data. Later, he does some research about each model of car on the internet. And finally, Jake makes a spreadsheet that includes each car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a navigation system. So in this particular case, who are the individuals in Jake's study? Well, the individuals in Jake's study are going to be the cars that are driven by students at his school. Oops. Okay, now notice I've gone into a little bit more detail than just saying cars, because these are not just any car, these are the cars that are driven by the students at his school. So now, what variables did Jake measure? And then we want to decide whether each of these is categorical or quantitative. So for each of these cars, he looked at the model, the year, the color, the cylinders, the gas mileage, weight, and if it has a nav system. So model. The model of the car is basically what kind of car it is. So this is going to be a categorical variable. It's not going to have a numeric value attached to it. Now the year. Depending on how we're using year could be something that's categorical or quantitative. In this case, the year could be something we take an average of. We could find the average year of all of the cars at school. So we could say that this is quantitative. The car's color, of course, color would put it into a category. The number of cylinders is going to be probably more of a category than a quantity, because I don't think we would really look at the average number of cylinders, because I don't think it's going to tell us anything. If I'm wrong, we can talk about that later. There is the potential that this could be quantitative. He's also, looking at gas mileage, which of course is a quantitative value. He's looking at weight, another quantitative value. And then the last thing he's looking at is whether or not it has a navigation system, so that would be categorical. Okay, so these are the individuals, the things that we're studying, and then their variables, the actual characteristics that we're collecting information on. And we've decided whether each of these is categorical or quantitative. All right. Now the second question says, Mr. Buckley gathered some information on his class and organized it in a table similar to the one below. So in this table, we have the student's name, right? Their specific name, their gender, ACT score, favorite subject, and GPA. So let's see, what are we going to do with this information? All right, what individuals does this data set describe? So this data set describes students in Mr. Buckley's class. Okay, identify each quantitative and each categorical variable. So let's see, for our quantitative variables, what quantitative variables do we have? We have ACT scores, and we have GPA. For our categorical variables, we have their gender, and we have their favorite subject. I would not consider their names to be a categorical variable, as it is just an identifier, a way to identify these students. It's not really placing them into a category. All right. Oops, scoot over this way. The next says describe the distribution of ACT scores. So we want to talk about what we see in those ACT scores. So I'm going to come back up here for a moment and look. ACT scores are numbers that happen to be between 28 and 34. All right, so the ACT scores are from 28 to 34 with no values repeating. So we know that those values are happening only one time. Okay, and then our last question says, could we infer from this set of data that students who prefer math and science perform better on the ACT, and explain? So let's look at the kiddos that prefer math and science. So we've got here, let's see, statistics, biology, algebra. So that's the 34, 35, and 33. So the three higher scores were the students whose favorite subject was a math or a science. So this data would lead us to believe that students who prefer math and science perform better on the ACT. And we know this because the three highest ACT scores in our set were students preferring math and science. Okay? Now, again, if you have questions, we can talk about this. We're going to do some more examples as we work on section 1.1 in class. But I wanted to give you an idea as to some of these definitions so that as they come up, you will feel more comfortable. All right, thanks.